Jet streams are another name for fast-flowing currents of air. There are many different jet streams that exist at both high and low levels in the atmosphere. Each has an important role to play in the weather experienced on Earth. The major jet streams that circle the Earth are found just below the tropopause at a height ranging from 9 to 16 kilometers and can reach speeds over 200 miles per hour. They are hundreds of kilometers wide but only a few kilometers deep, so are often described as a ribbon of very strong winds. The major jet streams are the polar front and subtropical jets. These occur in both the northern and southern hemispheres and are part of the larger global circulation. The polar front jet occurs over mid-latitudes and strongly influences the weather over the UK and Europe. The polar front jet is a type of thermal wind that arises due to the strong temperature contrast between cold polar air and warm tropical air. To explain this further, imagine two columns of air, one in the cold air to the north of the jet and one in the warm air to the south. The top of each column is bounded by the tropopause. A shorter column of cold air exerts the same surface pressure as a taller column of warm air. This is because in the cold air column the air is more dense. This causes atmospheric pressure to decrease more quickly with height. In the warm air column, pressure does not decrease as rapidly with height because the warmer air is less dense. The tropopause in both columns is at the same atmospheric pressure. So if you were to climb to the same height in both columns, you would find that you would be at a lower atmospheric pressure in the cold air column and a higher atmospheric pressure in the warm air column. The pressure difference caused by this temperature gradient produces a pressure gradient force. The pressure gradient force acts from high to low pressure, so theoretically in the northern hemisphere, air would flow from south to north. But the Coriolis force resulting from the Earth's rotation causes the air to move to the right of the direction of motion in the northern hemisphere and to the left of the direction of motion in the southern hemisphere. In both hemispheres, the jet stream flows parallel to this temperature gradient, moving from west to east. Theoretically, this jet encircles the Earth in a continuous line, but in reality it is more broken up, as differential heating of land-sea masses lead to west to east temperature contrasts as well as north to south. As the polar front jet forms due to the temperature contrast, the stronger the temperature gradient, the stronger the jet. This means that the jet is stronger in the winter than the summer as the poles cool during the winter months, increasing the temperature contrast. In the northern hemisphere, the jet tends to be further south in winter and further north in summer. This is due to the tilt of the Earth, and that in the winter, the northern hemisphere is tilted away from the sun, and in the summer, it is tilted towards the sun. Mid-latitude low-pressure systems occur on the polar or northern side of the jet stream, while more settled, warmer conditions are found to the south. This gives us the wet and windy weather we often see in the UK during the winter months, as low-pressure systems are steered towards us. It can also lead to some disappointingly wet summers if the jet stream remains to the south of the UK. A stationary jet stream pattern will bring frequent low-pressure systems to the same region. When warm air moves further north than normal, or cold polar air moves further south, this can change the prevailing west to east jet stream pattern. This causes the jet stream to buckle, driving depressions towards different regions or blocking their movements altogether. A straight west-east flowing jet stream won't have much impact on the development of new weather systems or strengthen pre-existing ones. When a jet stream meanders north and south, air accelerates and decelerates around the bends in the flow. These areas of changing speeds are our development areas. Where the air is accelerating, more air is leaving than entering a certain point. This means that the air is being depleted at this point. To fill this depletion, air from below rises. When air rises, it forms clouds and precipitation. Winds at the surface converge to this rising air column, which causes surface pressure to fall, and a low pressure system may develop or deepen further. So whilst a jet stream is just an area of fast flowing air, it has a fundamental effect on our weather.